So there are some genetic mutations that cause Alzheimer's, but that's really less than 1% of the population.
Women are twice as likely as men to have anxiety and depression. We're 3 times more likely to have an autoimmune disorder. We're 4 times more likely to have headaches and migraines.
Nuclear medicine is really code for radiology with radioactive isotopes. So when you look at scans of the brain where some parts are blue, some parts are red and yellow, that is nuclear medicine. We look at functionality inside the brain, the biochemistry of the brain. And I thought it was the coolest thing ever, so that's what I wanted to do. And they immediately put me to work on a project about Alzheimer's disease because I was so interested in that. And I never stopped. So I've been working in the field of Alzheimer's
It's driven
forever.
by your family members.
Yes, and specifically, I was interested in prevention of Alzheimer's and what causes Alzheimer's, what triggers it, and what do I do to stop it, right? And so then I moved to New York to look at the genetics of Alzheimer's. And within a couple of years, I was just so disappointed. Because, I mean, in a good way, because it turns out that genetics doesn't play such a big role as we previously thought it would. So there are some genetic mutations that cause Alzheimer's, but that's really less than 1% of the population.
Less than 1%
Less than
of the
1%
population
of the
is a
population.
direct genetic mutation resulting.
Yes, less than 1%. That is not to say that genetics don't count. Of course, everybody has a genetic makeup. We have genetic risk factors, but they're not as impactful as we previously thought they would be. And so I started thinking, well, what then makes the difference here? And that's how I started looking into lifestyle. And specifically nutrition, because it was really my research that pointed me to diet as a major factor that impacts the health of the brain, because I was looking at everything. I was looking at exercise, intellectual activity, diet, nutritional quality, vascular risk factors, all sorts of vascular risk factors that are known to impact the brain, obesity, diabetes. And when you put them all into your statistical model and you have the brain as something you're trying to predict, diet is the one factor that kind of always stands out, accounting for everything else. So that really convinced me that the diet had a huge role. And then I started a lab when I was at NYU. It was called, it's not a great name, but it's the Nutrition and Brain Fitness Lab. So scientists are very to the point. Nutrition and Brain Fitness Lab. And we were doing brain scans, which is really, it was really new back then, because everybody would just measure your diet today and then wait 10, 15 years until you either developed Alzheimer's or do not. Right, and then they would collect information on hundreds of people and then go back to the data they had collected 20 years prior and go like, oh, the people who 20 years later developed Alzheimer's ate a lot of saturated fat, a lot of trans fats, a lot of cholesterol, and the other people did not. But that's really bypassing the brain. For me, I want to know what's happening inside your brain as you eat certain foods, as you follow a certain diet, and can I change it? So I decided to use brain scans to do that, which is still kind of not really common practice.
It is definitely not. Definitely not. And you actually talk about the fact that the brain has really its own unique diet. That, you call this neuronutrition. And it's different from that of the rest of the body.
Yes, it is.
Which is really interesting. So why? Why is that?
So I also thought it was really fascinating. As a scientist, we're not trained in nutrition, zero. Medical doctors are usually not trained in diet or nutrition either. So when I was studying, I studied a lot of biochemistry. And I was reading all these names like magnesium, potassium, sodium, phospholipids, choline, and I never questioned, but where do they come from? Right, I just assume, well, it's something that's inside your brain.
For me, same thing.
Right, and instead, they're from the foods you eat. And that was, for me, it was really like, whoa, I never really, I never thought about it. And I took a lot of biochemistry, a lot of neurochemistry. And so I started doing a lot of research in that regard. And most of the studies are from the 70s and the 80s. Like, they were done so long ago that basically we have lost trace, because they were published in print, right? There are no electronic copies of that. So I had to go back to the library which is a fantastic experience. So quiet. And really just request, scanned copies of these super ancient papers. But it turns out that, so the way the brain works is fascinating to me. So the brain is an incredible organ. And it's actually it's the most protected organ in the entire body. And that's in part why we don't associate that with food, because we're taught in neuroscience school or in medical school that the brain is isolated from the rest of the body. Right. It's literally shielded by a blood-brain barrier, right, that just enables specific substances to go inside the brain and kind of precludes access to everything else. But the truth is that this barrier has little gates, right, that are specific for the nutrients that the brain needs. And the brain itself opens the gates and then closes them back once it got the food it needs. Right? So there are specific gates that tell us what kind of nutrients are good for the brain and needed by the brain, because these are the only nutrients that the brain has gates for. Right. And then can get inside the brain. And they're really a handful. There are about 100 nutrients that are important for health overall, but the brain only has access to, I'm going to say 30. And we need to constantly replenish these nutrients because the brain needs them. Yeah. Right? We have little sugar gates. So the brain, when the brain glucose levels go down too much, then the brain will just open the gates and allow the glucose to flow right in. And when it's done, the gates close. So it's not us. We're not necessarily influencing brain nutrition as much as the brain itself saying, oh, I'm hungry. I'm not hungry anymore. And that's very special because it doesn't happen in the rest of you. And I thought it was beautiful. Right? It's such a strong protective mechanism that also guides us in terms of what kind of foods and nutrients we should be eating on a daily basis, and what kind of foods and nutrients are not that helpful instead, at least for the brain.
There are so many interesting things in your book, and the way that you stated certain things really just kind of like set off a light bulb for me. And I want to ask you about what makes brain cells different from other cells in our bodies.
They don't die.
Yes.
Yeah, they're irreplaceable. So in the rest of the body, all the cells regenerate. So there's a specific turnover. Like, for instance, red blood cells die and get replaced all the time. Hair. People lose hair all the time, but then they grow them back. And that's why even short diets have an impact on the rest of the body. Because your cells have a turnover that can easily be modified, right? So when the new cell is born, you are affecting the development of the new cell. So you can kind of control and guide your body to do certain things. Not inside the brain. So our brain cells are born with us, stay with us for a lifetime, they die with us. And the way it works is then there's an explosion of neurons as soon as we're born. And then there's actually a lot more brain cells inside your head than stars in the Milky Way.
See, this goes back to that Star Trek that I was talking about at the beginning.
Yeah, everything is about Star Trek, yes. But then as the baby develops, some of the connections, some of the neurons are lost. And then by the time we reach adolescence, we pretty much have all the brain cells we're ever going to have. And there's been a lot of work showing that neurogenesis continues also in the adult brain. So neurons keep growing and keep being formed. But in reality, it's just really a minority of brain cells. They're just
certain places in the brain.
Yeah, they're like in the hippocampus, in the memory center of the brain, and in other parts. But by and large, that doesn't really happen. If it does happen, it's dendrites. So it's like the appendixes of the neuron, not the neuron itself. So we really have to take care of our neurons because they can't just be replaced.
I think that's one of the biggest insights I want people to get today is how important it is to take care of those cells because you don't get new ones.
You don't. Also, you can't change them as easily as the rest of you. So if you read like in a book that in 21 days you're going to change your brain forever, it's just not true. It's impossible. It is biologically impossible. It takes time. It takes time and consistency.
And also there's something interesting about the brain. And I would see this, of course, when people coming into my office experiencing, migraines and headaches. They're thinking, and I remember growing up, like you think your brain hurts, but that's not actually reality.
And no, it's your muscles in the neck and even here in the head.
because the brain cells don't have pain receptors.
They do not have pain receptors, so the brain cannot feel pain.
That's nuts.
Yeah.
And so even with that said, the brain not having pain receptors, it's not like your hand that can tell you that it needs some treatment, right? So can you talk a little bit about that?
Yes. So, well, the brain is not able to feel pain because the brain is in charge of feeling pain everywhere else in the body and making sure that we address that pain, right? If we had pain receptors in the brain, we would be really in trouble because we just couldn't think straight most of the time. And the problem with that is that it's very hard to understand the health status of your brain, that we have no access to what's going on inside our brain. Is our brain in trouble? We don't know. And we will not know until there are symptoms that become evident in terms of behavior or like movement disorder or insomnia. Or basically we need a deficit to know that the brain is in trouble. And that also speaks to prevention, really. Yeah. We should not wait that long because that means that whatever is going on in the brain that's causing the symptom has reached and passed a threshold that just makes the brain itself unable to deal with that. So by the time you get to the point, you have a disease or you have a condition that is severe and needs attention.
And now we're able to look at the organ that was so hidden and so protective, and you can see where the potential areas might be or potential areas of trouble, and you can prescribe certain plan of action based on that.
For sure. We do, so the Alzheimer's prevention clinic that I'm associate director of, we do brain imaging on all the patients in my studies. And also I used to do it at NYU for 12 years before I moved to Cornell. And in younger people, it's rare to find like an actual severe problem, but it's very common to find aneurysms that are still growing, brain tumors. They're so common. Wow. They're so much more common than anybody would imagine. And they're not necessarily malignant, they could be benign, but it's something that requires attention. Right. And if you have some symptoms of memory loss and confusion, it's very likely because something is pushing against your brain and it's creating issues. Or hydrocephalus, like when you have too much fluid inside your brain, or brain inflammation, that's a problem. Or brain atrophy is something we need to address. And a lot of things that happen in the brain are really related to food and to food choices, because the brain uses neurotransmitters to communicate, for brain cells to communicate with each other. They use neurotransmitters like serotonin, which I'm sure you talk about in your book, dopamine, acetylcholine, which is the neurotransmitter that makes memories inside your brain. And they're all built on food, on very specific nutrients that the brain needs in order to make these neurotransmitters.
Yeah, and I want to get all into that. I want to ask you first about this concept that the first time I've seen this was this concept of brain reserve.
Yes.
Can you talk about that, please?
Sure. So because brain cells are by and large irreplaceable, the health and the quality of your brain cells give you some kind of reserve, which is basically, it's like the higher the quality of your cells, the more resilient your cells are, the healthier your cells are, the more interconnected your brain is, the higher its ability to withstand insults down the line, right? So it makes sense that the healthier you are, the better you'll be able to face a number of issues down the line. You get a cold, you just get back in shape in a day. But if your baseline is not that good, then it's much easier to get sick or to be more vulnerable to a number of things that can happen.
So it's kind of like a reservoir,
yes,
like a just utility can go in, if it's built up in a strong way.
Yes.
Okay, so we really want to...
It gives you resilience against disease and against aging. And it's something that we need to cultivate really over a lifetime. And it's not just genetic. So when this concept developed, it was assumed that your genes played a huge role in determining your brain reserve. right? And then some people are just more genetically blessed than others. And now instead, it turns out that it's really, sure, there is a genetic component. There's some kind of blueprint that comes from your parents and from your DNA. But the way you live your life has a huge effect on the health of your brain.
Yeah. So shout out to people that are blessed with the good brain, but also we all really are. We have so much potential, and man, this is so fascinating. So let's talk about food. Let's talk about how food relates to the form and function of the brain. First, let's start with the form of the brain itself. What are our brains made out of?
Well, our brains are made of food, are made of nutrients, right? So the brain is made of chemical.
Wait, hold on. So I just want people to get this. Your brain, responsible for everything in your reality, is made of the food you eat. Please continue.
Well, so the brain is made of nutrients. The brain is made of chemical molecules that we call nutrients, with the difference that the brain makes a lot of the nutrients on its own. Right. So,
which is different for people, because we might think like these Cheetos or whatever is going to become my brain. It doesn't work like that.
No, it doesn't work like that. Although they will have an impact.
Yeah, definitely have an impact, but more likely, you can make other tissues out of these different foods, whereas your brain makes a lot of these nutrients or these compounds itself, which is very, very fascinating.
And I think it's important to clarify that, I've read it very often that the brain is made of fat, and so we should eat a lot of fat to replenish brain fat. And cholesterol is a very prevalent brain fat, and saturated fat is prevalent in the brain. But in truth, the brain makes them on its own. So cholesterol is made only by the brain as soon as we're born. And brain cholesterol is completely sealed away from the rest of the body for the entire time that we're alive. There are no gates in the blood-brain barrier for cholesterol. So no cholesterol from food will ever be part of your brain. So that's the first thing. Saturated fat, there are gates for saturated fat, the smaller ones. But what happens is that the brain opens the gates when we're little.
Right.
So children, all the way throughout adolescence, but then these gates pretty much close.
And that makes sense because the
neurons are done, right? The brain has already all the neurons that it needs. And so cholesterol and saturated fat in the brain only have a structural role. The brain cannot burn fat for energy. It is the only organ in the body that just can't burn fat for energy. So whatever fat is in the brain is just to give it structure. Right, and to just keep the neurons in a certain position and to wrap them with cholesterol and other fats so that it acts like a conductant, so that the information, the electrical stimulus can fly faster from one end to the neuron to the next neuron.
Because the physical brain itself is mostly fat and water.
It's mostly water, 80%.
Water, and then fat, and then protein.
Fat and protein is kind of a tie.
Pretty close.
Honestly, yeah. Once you take water out of the equation.
And then probably vitamins and minerals.
Yes, and very, very little carbs because they're just being used instantaneously. They just don't have time to sit around.
But a lot of those fats, and again, it makes sense as well, just with nutrition for an infant, for example, you're going to have that constituent, breast milk. It's going to be more saturated fat.
Yeah, you need
it to grow. That makes so much sense. But
then you don't need it anymore when your brain is done. Right. Once you have a brain.
Yeah, I don't know who's making like breast milk smoothies out there, but well, in truth, I mean, I guess if you're getting any kind of milk, never mind.
No, well, in principle it makes sense, but not after a certain age.
Right.
I think. But so the only kind of fat that can get inside your brain and the brain needs and wants is called long-chain polyunsaturated fat. Which in English, so that would be omega-3 and omega-6 polyunsaturated fatty acid, or PUFA. So that's salmon.
I think it's terrible. Like that acronym it just sounds bad, right?
There's PUFA, MUFA, SFA. MUFA,
oh
monounsaturated.
I don't know if somebody called me a MUFA. I don't know. Like there's fighting words. Oh my goodness. So, but those omega-3s and omega-6s specifically those are essential.
Those are essential fats. Yeah, those are the only essential fatty acids
get those
that the brain
via our
cannot
diet.
make. and we need to eat them daily, especially the omega-3s, because the typical Western diet is pro-inflammatory. It's very rich in foods that contain a lot of omega-6. And so usually the ratio is like 10 to 1 or 20 to 1, whereas a good ratio for a healthy brain is more like 2 to 1. So 2 omega-6 for every 1 molecule of omega-3. That's the good ratio. Let's say 4 to 1 is acceptable, but 10 to 1 or 20 to 1 is too much pro-inflammatory fat.
Yeah. And I guess like a systemic inflammation, like that's going to affect our brain probably as well.
Oh, for sure. Yes, yes. So the brain is the most metabolically active organ in the body, right? It takes over 20% of the entire energy production inside the body. But the brain is also really delicate. It's very, very sensitive to oxidative stress, which is the formation of free radicals. Yeah. And so it's very easily inflamed and oxidized, which is like the rusting effect that makes your cells age faster. So a pro-inflammatory diet just literally makes your brain age faster. You don't want that.
We don't want that.
No.
Oh my goodness. So physical structure, we've got water, fat, protein, minerals and vitamins. Yeah. Specifically, and we'll get into some foods and just dive a little bit deeper on those omega-6 in a moment.
This is a lot of chemistry.
So I want to ask you about, again, just to reiterate a little bit about this blood-brain barrier, right? Or the BBB.
BBB, yes.
Since we're making acronym, not Big Baller Brand, so no disrespect to, is it LeVar Ball? I don't know. The Ball family. Just, don't worry about it. You just keep doing science. But this blood-brain barrier is very specific. And you said there's about 30 things, just around 30 things, 30 nutrients that are going to be able to actually access and get
in the brain
itself, because your brain is very selective. Even though it's very metabolically active, I think it's somewhere it's like using like 20-25% of your caloric intake.
Yeah.
Crazy. Yes. But it's very selective. It's very choosy.
God it does now.
Yes, exactly. It's a choosy lover. So I want to just circle back really quickly and ask you about the cholesterol. So the cholesterol, obviously dietarily, we're seeing new insights about it being important but first of all, your body's making a nice amount of it, your liver, to do these processes, because it's a kind of a prerequisite to making sex hormones, for example.
For sure.
But that dietary form of cholesterol is not the same that you're going to see in your brain, because again, your brain is able to make its own.
Yes.
Is that right?
Yes. So the brain makes neurosteroids.
Okay.
That are different from the rest of the body. So and cholesterol is a special blend inside the brain, which is different from the rest of you. I mean, it's the same substance, but it has different uses and different functions, and just can't get in touch with the rest of the cholesterol. So, there's blogs or books that say you should eat a lot of fat to get smarter or happier or whatnot. It's just not true. It's just plainly not like true. That. No, but they can increase your risk of heart disease.
Yeah.
Instead. So that's
something,
a lot of the wrong stuff. So we have shown that even though these fats, cholesterol, saturated fat, trans-unsaturated fat, they can't get inside the brain, they do have some indirect effects, because not for everybody, but in some people, they really can produce inflammation. And the inflammation that you have in the rest of your body is able to get in the brain as well, because cytokines can cross the blood-brain barrier. So if you have inflammation in the rest of you, it can also affect your brain indirectly. And of course, if your heart is suffering, then your brain suffers as well.
Right. If it's bad for your heart, it's bad for your brain.
Yeah. There's a saying in cardiology that you're only as old as your arteries are, which is so true. It's really true, because if your arteries are not nice and clean, then blood can't get to the brain. Oxygen can get to your brain, cannot get inside your brain. And then your brain starts aging faster because it really needs it, like constant. Like blood flow to the head is a major predictor of brain health, brain function.
So we've got water.
We've
got fat, slightly more fat than protein is close. So with protein, all protein or essential
amino acids.
Yes. So those are the ones we're looking for in our diet.
Yes.
So with that said, these essential aminos, so those are some of the ones that the brain has those gates for.
Yes.
Okay. All right, got it. So there's certain vitamins, minerals, proteins, and fats. Yeah. So I want to now talk about function. So we talked about form, kind of what the brain is made of. So let's talk about which nutrients do we know are critical for the function of a healthy brain. And I want to go first through some lesser known ones and then get more to the known ones. So it was a lot, everybody at this point hopefully has heard about the importance of omega-3s for their brain. But now to know specifically from you, a neuroscientist, that this is actually getting there, I want to talk about that for sure. But let's talk about choline. Yeah. What is that?
Let's talk about it. It's a B vitamin. So choline is a B vitamin that is used by the brain to produce acetylcholine. And acetylcholine is a major neurotransmitter that the brain uses to produce memories. So we need B vitamins, especially choline. Did you say choline or choline?
Choline.
Choline. Okay, so I'll say that.
But I like how you say it too.
In Italian, I say cholina.
Oh my goodness, that's the cutest thing I've ever heard in my life. So choline, and for me, you know, I would go for eggs. Yes. I would go for bee pollen. Is a good source.
Royal jelly, yes.
Yeah. See, pollen. And I didn't see this in your book. I don't know. I'm not through all the book yet, which I love this book. There are certain books that I just feel that it's like mandatory. Like if you really want to be really masterful about your health, I think it's so important for us to understand our brains.
I agree.
And I cannot believe there's not a brain food book specifically, and then created by somebody who's been in the lab and like looking at this stuff. And it's just like, you're basically like an X-Men. You're like a mutant of health, you know, like to have both of those sides.
It is bizarre.
And so it's like a big confirmation for certain things, and other things just like, well, that makes sense. You know, let's just like toss that whole concept out. And so I love your book. So
thank you.
Choline is one of them.
Yes, I have more sources. Oh, can we talk about caviar or fish eggs?
Let's go. Let's do
it. So
what's the other? There's caviar and there's some other little eggs as well.
Salmon roe.
Roe, yes, the roe.
Yeah,
okay.
Because
row your boat.
You know, I didn't know until the book came out that in the States, caviar is really fancy food.
Yeah.
In Italy, there is no distinction between the fancy black caviar and just fish eggs. We just use the word caviar for everything.
Yeah.
And so when the book came out, I even have it on the cover. If you see one of my this is caviar, right? It's salmon roe.
Yeah.
It's my number one brain food. And everybody was like, but it's too expensive. I was like, but fish eggs are not really that expensive. And so I learned that you have to clarify salmon roe or fish eggs.
Yeah. When I heard caviar, I immediately thought of like Scrooge McDuck. Like super wealthy, you know, Grey Poupon, you know.
It doesn't have to be. No. Fish eggs are actually not that expensive. But so they're the best. The nutritional composition of caviar or fish eggs in general is pretty much a perfect complement to the nutritional composition of the brain. It's really a one-on-one because they're very rich in choline and phospholipids, omega-3 fatty acids, a good amount of protein, but they also contain antioxidant vitamins. It contains vitamin A, vitamin C in some amounts, a little bit of vitamin E, and mostly selenium. And selenium is a very rare mineral.
And it's super, super important. Responsible for a lot of stuff.
It's very important because it's a strong antioxidant. And it's really hard to find in foods, like Brazil nuts are a good source, but caviar or fish eggs are an excellent source.
Look at that. Yeah.
I always mention it because, of course, nobody eats caviar every day.
Yeah.
But, you know, once in a while, if it happens,
add that to your...
So you know, it's also really good for your brain.
Yeah, add that to your superhero utility belt of things to have access to, you know. But it's just having the awareness.
Yes,
and
it's
also,
just a curiosity.
Yeah, and the stigmas attached because
there's actually a reason to eat it. It's a good reason to eat it.
For me, hearing that, like immediately in the book, I'm like, oh, that's fancy. Like it popped up in my mind, but it's a cultural difference, you know.
It is.
Okay, so we've got choline is one. Let's talk about tryptophan.
Let's talk about tryptophan. So tryptophan is an essential amino acid. So it comes from protein that the brain uses to make serotonin. Serotonin is a neurotransmitter that is involved in a number of functions like mood, sleep, but also in memory. We don't usually associate serotonin with memory, but actually has a really strong impact. And the thing about tryptophan is that, most people will just say, well, it's everywhere. And it's in many, many different foods. But the point is that it comes usually with a lot of other amino acids that compete with each other to get passage inside the brain. So the gates are the same. Right. And so tryptophan is usually the one that's left behind. So I think it's important to focus on foods that contain more tryptophan than the other ones.
Why is tryptophan left behind? Is it slow? Is it?
I don't know. I don't know.
Because
I think it's just not as abundant. So if you have a lot of like tyrosine and a little bit of tryptophan, you're much more likely to get a lot of the amino acid that is more abundant.
Yeah.
And that's why you need foods that are particularly rich in tryptophan.
That's super important. So this
especially before bedtime.
Yes.
Right?
And this essential amino, so it's used to build serotonin, which is a precursor for melatonin.
Also.
All right. So, but also there's so much news today about serotonin and like the kind of this happy neurotransmitter, and then even antidepressants, a lot of them, the SSRIs. So what the most important thing is, like, are we even making it? In the first place, right? Yes. And so this is one of the keys. So tryptophan, but when I hear tryptophan, because just, past and going through life, but I know better today, but I would associate like Thanksgiving turkey. And you wrote about it in the book too, because you're like, oh, we eat the turkey, tryptophan, you get sleepy. No, it's because
you eat too much.
Yes, you just like ate like there's no tomorrow, because I've done that. Like, this is the last day of my life. I'm going to eat everything. That's how we get on the holiday. Like, I'm just going to, and it's an experience, we feast, but it's not the tryptophan, by the way.
Milk is a better source, like whole milk. And I'm sure everybody does it. And when you're little, you give warm milk with honey to kids to help them sleep.
Yeah.
And that's because there's tryptophan in the whole milk. It's a good source. And if you combine carbohydrates with tryptophan, that actually helps push the tryptophan inside your brain.
And you have
so
lactase.
That's why you want to.
There. Oh, with the sugar too, from the honey.
Yeah.
Okay.
The sugar from the honey.
So, but now are we talking about milk from
cow usually, but goat is actually better.
Okay. And also, like, is it genetically
modified? No.
Are we talking about like the cows like eating, I don't know,
corn,
candy, right? Because true story, there was this big spill that happened. It was like all these red Skittles that coated the freeway. You didn't see this?
No.
Okay. I mean, this was a while back, but this was going for feed for livestock.
Really?
Yes.
Wow.
Nuts. I think this was in Florida.
Okay.
I got to look this up. We got to put it in the show notes, so it's not like, wait a minute. But some people are going to know what I'm talking about. And it's crazy, like the stuff that and I've been pressing this in the culture. Now I see it everywhere. I'm not saying that I originated this idea, but you are what you eat. Yes. It's not just you are what you eat.
No, it's true.
And so, like, making sure that we're getting these different animal foods from healthier animals. And of course, you do make that distinction in the book as well.
Yes. So I believe in organic, especially for women, if we can mention that.
Yeah, absolutely.
So for women, changes in hormonal levels are a natural problem that so many people just don't ever get to talk about. Women go through a series of endocrine transition stages as we mature through puberty. But then the most shocking one, perhaps, is menopause. Right? Yeah. And menopause is the loss of estrogen and progesterone and other hormones that impacts everything inside your body, but also your brain, which we have shown with brain scans, how for many women, as they go through menopause, that's when Alzheimer's really begins in their brains.
That's interesting.
And something to know about women's hormones is that there are many substances that we put into our food, that we put in the environment, that we put on our skin, that are xenoestrogens. They're foreign estrogens, and they are known to really mess up your own estrogen inside your body. So they act like estrogens, but they make everything worse. Like if you have a predisposition to breast cancer, they're likely to push you to actually get breast cancer. And this is the Society for Neuroendocrinology's And they put out a warning because we are drowning in plastic. And if you have food that is contained in plastic, and if you heat up the plastic, then all the substances that are known to mess up your estrogens will just leak into your foods. And then you end up eating them. And that really creates issues like man boobs, or the fact that girls become women at such a young age nowadays.
This is
it's not just
first
normal.
Grade, right? It's absolutely nuts. And like you just said, so these xenoestrogens fit into receptor sites and basically turn on these estrogen driven programs.
Yes.
It just all makes sense.
You said it really well.
And so, and so what's so interesting about it is, like you just mentioned, these xenoestrogens, maybe from bisphenol A or something like that, from plastics, which is a fossil fuel, right? And so this is, let's not even go down that. When we're talking about organic and
but that's why
pesticides, herbicides, rodenticides, many of them are estrogenic.
Yeah, they're all estrogenic.
Or neurogenic. Some of them are
estrogen is a brain hormone.
Yeah.
We tend to associate hot flashes and night sweats and depression.
We're not putting it together
with your ovaries, but these symptoms don't originate in your ovaries. They start inside your brain, because estrogen has a strong effect inside the brain. Wow. And food has an effect as well, because food also impacts hormonal health in a big way.
Yeah. That's what this is all about.
In particular, fat from animal food, that also impacts estrogen production, and not in a good way. It's been shown. It's not my own opinion. It's been shown to impact estrogen in women.
So you can't just go ham on ham,
No, especially for women. It's not just heart disease, because usually people are like, well, my heart is fine. I'm like, yeah, your heart is fine, but how about the rest of you?
Just be mindful. Functions. That's what I want people to do, is don't get caught up into some,
fad.
I was gonna say fancy, flashy diet. That's just all animal products. You need to eat 80%. You got to do what's right for you. First of all, and not just buy into this, and also be aware of some of the potential dangers. And not to say that the amount that you're taking in, maybe it's a smaller amount, and that's fine. But you've got to look at the data. You've got to play the long game. Yes. Right? Just because bacon is super hot right now doesn't mean we got to get, bacon for breakfast, lunch, and dinner, And shout out to bacon, chocolate covered, they're doing all kinds of crazy stuff with bacon. Anyways, so let's go to phenylalanine.
Phenylalanine, yeah.
Yeah, let's talk about that.
Okay, let's talk about it. So dopamine is another neurotransmitter that has a lot of different function in the brain. It's really important for movement and coordination, but also for reward-driven behavior and motivation. And dopamine is made of an amino acid called tyrosine, and tyrosine in turn is made from phenylalanine. So you need to make sure you have enough in the diet, but that's easy enough to do. It's not a difficult source to find. It's very abundant in all sorts of animal foods and fish. I would say fish if you need to get good lean protein. Fish is a great source. Also, fish is a great source of omega-3 fatty acids.
Right. So
the fat
get the power packed.
So you can get And then everybody goes how about mercury?
Yeah.
Right.
How about it?
So there are. It depends on how big the fish is, right? So the bigger it is, the higher the chances of mercury contamination. So it's really important to go for fatty fish for the brain. I'm talking about the brain, right? So fatty fish, especially cold water fatty fish, which is like salmon, herring, trout, but also the smaller ones like mackerel, bluefish, sardines, anchovies. And the smaller ones like anchovies and sardines, they're very unlikely to have any mercury. Yes.
Interesting. And
so
your body can actually tolerate some, by the way.
Yes,
it's not like mercury touches you and you disappear.
No, of course. Well, so how much fish do you eat?
Yeah.
I mean, we're talking trace.
Yeah.
Right? Trace amount of mercury, not the whole vat. I mean, there's always something to be said about common sense, I think, right? You can't eat fish every single day just because it doesn't make sense to do that. And also you can't eat a pound.
Yeah.
Right? A good portion, depending on how tall and how muscular you are, but usually 3 ounces.
I didn't know you noticed my muscles. So this is, I'm just kidding. So phenylalanine is a precursor, tyrosine.
Yes.
And then we get
dopamine,
which is, we're talking about our drive. We're talking about happiness. We're talking about reward. You
playing
need
games.
This one. Yeah.
When you're playing video games, it's dopamine that makes you feel like,
and you miss out on that without this. Wow. So by the way, another source, I'm going to throw this in here for everybody. It's a perfect place. Phenylalanine, spirulina.
There you
spirulina. You talked about spirulina in your book.
Yes.
So this is a brand new study. I literally just came across this 2018 study, brand new, just came out. This was published in Nutritional Neuroscience. Investigated whether it was possible to treat severe neonatal infection by administering a spirulina-enriched diet to the nursing mother. So not even directly to the baby, to the mom. And the researchers stated that severe infection and the associated brain inflammation can cause long-term changes to the developing brain due to oxidative stress, even after the original infection has been treated and it's gone. And what they found was, after they compiled the data, a spirulina-enriched diet given to lactating mothers reduced the level of brain inflammation. All right. So spirulina reduced the levels of brain inflammation and provided an antioxidant defense for the developing neonatal brain, which this is the questions that we would ask our incredible guests. Like, how are they actually measuring this stuff? And so she's actually doing the work and in the lab and looking at things like this. And so, by the way, guys, spirulina, it's not the best. Let's just be honest. It's not like, oh my goodness, I cannot wait to eat spirulina today. But it tastes really good in guacamole. I don't know if you ever had this.
No, I never tried.
Yes, put a little, but don't go too hard. Right. It changes to a weird color. It's like not from this planet, but it actually tastes really good. It's a good compliment. And it makes sense. Spirulina is one of the primary kind of protein sources for like the Aztecs. You know, it's just, don't get me started. But also, for me, I get this in a formula along with chlorella, moringa, and ashwagandha in this product called Organifi. And so this is the only, and one of the big issues is like, what are they doing to the supplement before they get it to you? Like, is this actually going to be a whole food kind of extract, or is it like heated, fried, dyed, you know, and it's just like, or a synthetic source of these nutrients. And so they do a low temperature process and they actually make it taste good. So this is, I've tried literally probably 20 different green blends over the years, in the last 15 years. Finally, one that tastes amazing, my kids like it, getting their dose of spirulina and moringa and all that good stuff. And I highly recommend folks check it out. It's Organifi.com/model. That's ORGANIFI.com/model. You get 20% off with Organifi. All right, so head over, check it out. It feels good. Like, it makes you feel clean inside. All right, so
I put it in my energy bars. I
you
make
do.
energy bars.
You make your own.
I make my own. I
You
don't
do that
trust.
too.
So yeah, I'll send you the recipe. And I put spirulina. So Lily, my daughter, also likes them very much.
I love that. What else you put in these, by the way, since you're talking about it? What else goes into the...
So I have bran, oat bran, flax seeds.
Yeah.
I use...
Omega-3s. There's ALA.
No, I don't do supplements.
No, the flaxseed.
Oh, the flaxseed for omega-3, yes.
But it's ALA, though.
ALA, yes. This is the vegan or the vegetarian plant-based source of omega-3s. So what happens is that the brain has access to ALA, EPA, and DHA, all three of them, but needs DHA the most. So the only natural source of DHA is from fish and seafood, basically. But the brain can use the other two forms and convert them into DHA. The problem with ALA is that over 75% is lost in the conversion. So when somebody is vegan and says, can I take these, ALA, the plant-based omega-3 supplements, they're like, yes, you can, but you need to take more to achieve the same result because 70% is lost. And one thing to keep in mind is that omega-3 actually interacts badly with specific medications, blood thinners, like aspirin. So it's very dangerous to take these supplements.
consideration. Wow. And
yeah,
so
for people over 60 actually is a big health hazard.
Yeah. And so folks that are taking a vegan approach is also the algae oils potentially could be
yes.
helpful
But
as well.
you need more
you
because
need more.
it's
Yeah.
ALA.
Still the conversion.
Yes.
But just getting more of a concentrated dose. So these are those areas of like whatever, might be ethics or whatever the case might be, where you got to get into like, what am I doing for for myself as a human versus, my belief system, and finding that line that you can straddle to make sure that you're still taking care of yourself.
Yes.
So last one I'm going to ask you about, again, there's so many things I want to ask you about.
More.
Is actually really quickly, can we talk about phospholipids?
Sure. So phospholipids are actually, that's really the main brain fat. Yeah. We always think about cholesterol, but the brain contains more phospholipids. And they really are so important because they keep your brain cell membranes fluid and flexible, which is crucial for the brain to function. Yeah. And there are many different kinds of phospholipids. There's like phosphatidylcholine, there's phosphatidylserine. So they are a fatty acid group connected with either amino acids or vitamins. Okay. Right? And so phosphatidylcholine, which is perhaps the most important in many ways, has the same origin, basically. So it comes from foods that are very rich in omega-3 fatty acids, but also sweet peas are really good sources.
Interesting. Interesting.
Like crustaceans, like crab and all kind of different fish and shellfish, but also sweet peas. There was another one, I wrote it down. Oh, cucumber.
Cucumber, really?
Yeah.
Huh. Yeah. Surprise.
Yeah. Not as much as fish, but you still get some. And also there's this thing, tapioca.
Tapioca, yeah.
There you go.
That.
So that's also a very good source.
Wow.
Do you? I don't know. I never tried it.
So it's great for like baking,
like
a lot of
flour.
Yeah. And it's especially like if you're using alternative flours instead of, the
wheat.
Yeah,
like
bleached,
flour.
fried, dyed, fricasseed, whatever flour. But, if people are using like coconut flour, it can really help to kind of add that missing note.
Bit more texture.
Yeah. So last one I want to ask you about, which wasn't the phospholipids, the omega-3s. So let's circle back to the omega-3s and talk about, you mentioned it several times, but let's pin down best sources because it's essential.
Right. So the best sources, it depends if we're interested in animal sources or plant sources. What do we start with? Animals, because they're better.
Both.
Right. So fish. Well, caviar is my number one, or salmon raw, or fish eggs are really the most, the highest and richest sources on the planet. Salmon is good, but not nearly as rich, frankly. Herring, mackerel, sardines, anchovies, trout. Fatty fish.
Got it. And then for the vegetarian side, we got
chia. Flax seeds. Chia, yes, but flax seeds are better. Flax seeds and hemp.
And hemp, seeds. Big fan.
Big in California. Chia seeds, walnuts, soybeans, and then oats, spirulina. That's what I was trying. Yeah, it's actually a good source of omega-3s.
Wow, so cool.
And wheat. Wheat, actually, believe it. Grains are not that bad, guys. Actually good for you.
Yeah. So, and there's so much in the book. And I want to share this study really quickly. A landmark study of 6,000 participants ages 65 years or older showed that people who consumed low quantities of omega-3s had a 70% higher risk of developing Alzheimer's than those who consumed more omega-3s.
Did you know about how women have been excluded from research?
No.
So many people don't.
That's the thing.
I would say most people don't know that. So many scientists don't know either.
I never thought of all the thousands of studies I've read. I've never thought about that distinction. And you mentioned it very clearly, that the medical system has kind of uniformly excluded women,
right?
And basically treating women as just smaller men when we're talking about the medical data. Can you talk about that a little bit?
Yes. So the first part of the book is really a description of how women have been systematically excluded from medical research, which is not to say there's a conspiracy against women, but it's just something that happened as a result of a number of biases, if you will. And so I use this term bikini medicine, which is an unfortunate term, if you will, but it's quite to the point, describing how historically most medical professionals really actually believed that men and women were essentially the same person, just with different reproductive organs. So setting those parts of the body aside, as if one could, meant that most professionals, most doctors would diagnose and treat both sexes the same exact way. And basically, there's a whole worldview that got derived from that model, which makes women's health, the field, biased to start with. Because if you go to a doctor and say, can you look at this female patient through the lenses of women's health, they're going to do a pap test to check your cervix for cancer.
Standard.
They're going to do a mammogram if you're over 42 or 40, depending on the doctor. They might do a blood test to check your sex hormones for fertility or menopause and whatnot. But again, women's health is confined to the health of our reproductive organs. And that's really a direct consequence of a very reductive understanding of what a woman is to start with.
Yeah.
Because clearly women are not the same as smaller men with different reproductive organs. We're somewhat different systems. Yeah. And it's not in any way to exaggerate the differences. So it's not like women have some parts that men don't have, well, except for the reproductive organs, right? But when we're thinking about, for example, women's brains, which is really the focus of my research, anatomically, we're basically the same, but the functionality of the brain is different. And there are so many things that can happen in the brain that happen more to women than to men, or only to women and not to men, and only to men and not to women, right? But we understand men's risk factors a lot better than we understand what can happen to women. Yeah. So that's really why I'm doing this.
Yeah, and it's so important because as you outlined, the first thing I want to make clear, which you alluded to already, is that it's not like some conspiracy, but there was some early reasons why this kind of evolved into this, which is women's bodies tend to create some curveballs when doing clinical trials, like pregnancy.
Getting pregnant was a big one. So what happened was that there was a drug, thalidomide, that was given to women, including pregnant women, to deal with symptoms like nausea. And then it turned out that the drug actually had a terrible impact on the baby. And many babies were born with deformities or with severe medical issues. And so the drug was reevaluated and was banned in the United States. But at the same time, the FDA really took a cautionary stance and decided to exclude women of childbearing age from experimental clinical trials, where you still don't quite know side effects as well as you should, right? But then
that's excluding a lot of people.
But that's excluding a lot of women because it's any woman from puberty through menopause, right? So what happened then is that I think it was really out of concerns for the babies and the women to some extent, the new mothers, that women were just excluded from all clinical trials, not the phase 1 clinical trials, but just from all medical research. And by doing that, women were no longer participating in research, but they were also no longer informing research. And it is true that our bodies are more cyclical in nature than a man's body, and if you're a scientist, you have to deal with that.
Yeah.
But that's not that hard to do, right, to be honest. And instead, a decision was made to just focus more on men, assuming that especially when it came to heart, lungs, and brain, that would also, whatever results investigators found, would also apply to women. And that turned out to be not the case in a big way.
And even when women are included, and again, just thanks to your data and me learning this, it tends to be everybody's lumped together. All the data is lumped together. It's not giving a distinction between this is something for women's health specifically, and this is something for men's health. And with that said, we parlay into this discussion of the female brain and how different it is under these different measures, whether it's like some kind of a nutritive intervention or medical intervention. It's going to impact women's brains differently. So I want to talk about the difference with the female brain because it's fascinating. So first of all, let's just talk about, number one, the physical brain itself is different.
A little bit. So The anatomy is not quite different. Like if you look at brain scans and you don't know the gender of the person that you're taking a picture of, there's no way of telling this brain belongs to a woman, this other brain belongs to a man. Other than, on average, women's brains are slightly smaller because we're just smaller on average than men. But once you adjust for head size, pretty much volumetrically speaking, there are no strong gender differences. The differences that matter most are in the functionality of the brain and the biochemistry of the brain. And I've been looking into that for a really long time because of personal reasons. I have a family history of Alzheimer's disease that affects the women in my family quite a lot. So my grandmother, was one of 4 siblings, and there were 3 sisters and 1 brother. And all 3 sisters got dementia and died of dementia, whereas the brother was spared. And that was quite shocking, also because I'm from Italy. As you know, I'm from Florence in Italy. And especially back then, there was no assisted living. So your grandparents live with you, period. And then the family, especially my mom, became the primary caregiver for my grandmother. And then my aunts started taking care of the other sisters who got dementia. Everybody, it was like a 10 years process. And it was very painful, as anyone can imagine. And that really led me to think about Alzheimer's disease as a connection with sex and gender, which was really not a topic of conversation back then. I've been doing this for almost 20 years. Just really, and I've seen the field just change so much. And something that many people are not aware of is that women's brains have very specific risks that we usually underestimate and kind of put down to, perhaps you're having a bad day or maybe you're PMS. But in reality, women are twice as likely as men to have anxiety and depression. We're 3 times more likely to have an autoimmune disorder, including those that attack the brain, like multiple sclerosis. We're 4 times more likely to have headaches and migraines, as any man knows. We're more likely to even get meningiomas, which are the most common form of brain tumors, especially during menopause. And we're far more likely to die of a stroke. And on top of all that, Alzheimer's disease, which is the most common form of dementia on the planet, affects more women than men. So of every 3 Alzheimer's patients, 2 are women, which means that for every man suffering from Alzheimer's disease, there are 2 women. And that's an enormous amount of women. In the United States alone, Alzheimer's disease affects almost 6 million people. And if we don't find solutions, by the year 2050, it's going to grow to like 15 million, which is like, for context, is the populations of New York, Chicago, and Los Angeles put together. So it's a huge amount of people, and 2/3 of all those people might be women. So we had some problems here, and it's important to find solutions. So this is really what I was trying to do with the book, not just be super depressive. It's not a downer, I promise. It's really
it's empowering.
About acknowledging the problem, explaining how we got ourselves in this situation, and what we can do to really reverse this problem and optimize cognitive health and brain health in women. Those are the scans I want to show you.
There are some wonderful brain imaging scans in the book as well, just to kind of highlight some of these things. We look at premenopause, postmenopause. The brain really does change.
It does change.
But one of those physical aspects, just to pivot back a little bit, and it just, of course, made so much sense when you talked about it, that one of the physical, it'd be difficult to see if you don't have the trained eye looking for it. But I guess the hemispheres of the brain for women, it's more, what's the right word for it?
Interconnected.
Interconnected.
Yes. Well, I think the technical word is structural connectivity. Yes. And so what happens, just taking a step back, just a quick one, is that women are born with 2 X chromosomes, and men are born with an X and a Y. And those genetic differences do matter also in terms of brain development. And I think it's important to clarify that because most people think of this XX and XY as only involved in reproduction. But in reality, there are many genes on these chromosomes that are directly involved in brain function. And something that is a curious fact is that the X chromosome, which women have 2 of, are much bigger than the Y chromosome. So each one has 1,098 genes, whereas the Y chromosome has only 78. Yes, and many of these extra 1,000 chromosomes that women carry are really involved in brain function. So there's something there that starts immediately at the time of conception, because the cell that is born with the XX is going to develop and mature and migrate differently than the other cell that is born with an XY. And one of the big differences is the type and quality of the hormones that are going to be produced in those brains. So the XY chromosome dictates that that baby is going to start making androgens, like testosterone, which are male hormones. So the brain, because these chromosomes are also part of our brains, right? And they're involved in brain function. So the brain is also really going to be wired to respond more to the androgens and testosterone, because boys have very little estrogens. For girls, it's exactly the opposite, right? We make a fraction of the amount of androgens and we make 1,000 times more estrogens. This is figure of speech. But our brains are really wired to respond to the estrogens. And the way that works is that we have little receptors in many parts of the brain that are specific to that type of hormones. So our brain tissue is populated by estrogen receptors that specifically bind to estrogens. It's like a key in the lock. And when the binding happens, then there's a lot of things that happen in the neurons downstream, especially energy production. So hormones, estrogens in particular, in the female brain are really strongly involved in energy levels in the brain. And so what happens as these baby brains age and go through puberty and then through a number of different phases of life is that at some point we reach midlife. And that's when things start going downhill for women, at least temporarily, because testosterone doesn't run out until late in life. Most men don't lose their hormones until they're in their 70s or 80s. Of course, there's a little bit of a change, but it's not nearly as dramatic as what happens to women in menopause and perimenopause, where we basically lose our hormones, like boom, they just literally peak down. And that has an effect on the brain, which we have demonstrated using brain scans, perhaps for the first time, as far as I know. So that was quite shocking, is that image in the book that you mentioned.
Yeah. This was like, because I think the issue is that we label these as sex hormones, and it's kind of the end of the story, but understanding there's so many more receptors, there's a lot more activity going on in the brain for women as far as estrogen and all the influences that this has. And so that starts to open up the case for when you shift away from having this estrogen production, and then we see paralleled all of these issues with cognitive decline, Alzheimer's, that are so much higher in women, and we're not talking about this. We're not having this conversation.
Right.
So estrogen is just, it's so much more than just a sex hormone. It's so much more.
Thank you. Yes. So hormones like estrogen are not only involved in reproduction, but also very closely in brain function. And estradiol in particular, which is the most potent form of estrogen, is really key for energy production in the brain, as well as growth, plasticity, and immunity. So what happens is that when your estradiol is high, as a woman, your brain energy is really high. But when your estrogens go down during menopause and perimenopause prior to that, then your brain energy also goes down. Your neurons slow down and they start aging faster. And studies have shown that this process could even, in some women, not all women of course, but in some women, that is correlated with the formation of Alzheimer's plaques or amyloid plaques. And we have shown that using brain scans that that's really true. If a woman is predisposed to Alzheimer's disease, that shows up during menopause, which is 50. is not age 70 or 80, it's 50 years old or earlier. I was just reading that 10% of menopausal women go through menopause before age 45. It's incredible, yeah.
Wow.
Yeah.
So with that said, some of the, so you mentioned that estradiol.
Estradiol. Mm-hmm.
So there are different forms of estrogen, which I think is important to mention. It's not just one thing. There's estrone and
estriol.
Estriol.
Yes.
And so when we're looking at, which we'll get to, hormone replacement or whatever the case, we have to be mindful, like what kind of estrogen.
We're replacing the estradiol.
And so
that is the one that your body no longer makes after menopause, and the estrone is the backup, whereas the third hormone, you only make it when you're pregnant.
So you got
and it makes you feel great, but only for a few months, and then that's it, you're on your own.
So we got people, estrogens coming off the bench when they need to, but it's such a bigger conversation.
Yeah.
And so let's talk about some of the impacts that estrogen has on the brain. So you mentioned like preventative, like when it's around, there's less of an incidence of, potentially the amyloid plaque formation.
Yes.
But what are some of the things that estrogen does for the brain? Like what benefits does that do for a woman's brain?
Well, many benefits. We refer to estrogen, and specifically estradiol, as a master regulator in the female brain, because it's really involved in a number of functions that you wouldn't even imagine, because we never talk about it. But really, energy is the most important thing. And I know you love biology, so I'm going to go into it.
Let's do it, yeah.
By energy, I mean the cerebral metabolic rates of glucose. So estrogen is something that activates neurons to burn glucose more efficiently. And glucose is the main energy substrate for neurons, especially, right? So over 90% of synapses are glutamatergic, and they really need glucose to fire. And the estrogen literally helps glucose enter the Krebs cycle and be shuttled into the mitochondria, which are the energy factory of the body and the brain. Yeah. So that's really important, because that's the way that your brain produces the most ATP. And I know there's a lot been said about ketone bodies, but with the research, if anyone is thinking, well, then I should go on a keto diet, right? What the research has shown is that as you go through menopause, what you really want to do is to treat the root cause of this. So you want to have the hormones that allow your brain to burn the glucose, because if you do not, what happens is that ketones are just not enough. And research has shown that, and at some point your brain just gets really confused and starts burning its own fat. And
the structural fats.
Yes, the structural fat of the brain. And that's why we find white matter reductions on brain scans. It's called catabolism. It's when, it's not a good thing. Let's just say that. So that's one reason that having enough of this hormone is really important, to keep the brain structurally solid and sound, but also to really support the functionality of neurons and just the health and the integrity of your membranes.
Yeah. This is so, again, super enlightening, and
I'm so glad I get to talk about these things. I'm usually more like, neurons burn sugar.
Well, we love to geek out.
Right.
And I love the fact that in the book you said this, and this is a direct quote. You said, Alzheimer's isn't like you suddenly caught a cold. Rather, the disease is the result of a number of genetic, medical, and lifestyle events that have been happening along the way.
Right.
Because what we tend to think is that it's just happened.
Yes, one day you go to the doctor and boom, you have a diagnosis.
Yeah. And if we're talking about the story of estrogen, it's a kind of it's a longer history, than my estrogen is turned off, or whatever the case might be. Right. This is something that with our lifestyle and with our focus on our brain health is going to determine what estrogen is doing pre-menopause, during, and after.
After.
Yeah. So.
Yeah, for sure. And it's important to talk about this, because that's quite an insight to associate menopause with Alzheimer's disease, right? Most people think of Alzheimer's as old age and menopause is middle age. But in reality, we know now that Alzheimer's disease starts with negative changes in the brain years, if not decades, before clinical symptoms emerge, which is like in the 70s. So the real onset of Alzheimer's is more in midlife, especially for women, and it seems to really overlap with the transition to menopause. And I want to add this, and then I'm going to stop the bad news. But for most women, menopause is around age 52 in the United States, 52, 53. But it can be much earlier, sometimes because of genetics, sometimes lifestyle, but very often because of medical interventions. And I would like to mention this because common examples are a hysterectomy and or an oophorectomy, which is the surgical removal of the uterus and or the ovaries. 1 in every 9 American women has this procedure done in the course of their lifetime, very often before menopause, when they're young, in their 40s. And we unfortunately know that having the uterus, and more so the ovaries, removed prior to menopause correlates with a higher risk of future dementia in women. So this is something that I realize is depressing news and it's very upsetting news, but we also really, we need to talk about it because so many women are not aware. Yeah. And it is important information to have because sometimes you get your uterus taken out because of fibroids. Yeah. You know, it's the most common cause of surgery. But we know from other work that very often fibroids respond to medical and lifestyle treatments. Yeah. So it's something that is worth looking into before your doctor even suggests the surgery. Yeah. So I just want to put it out there. It's one more reason to really consider reproductive organs not as something that you can just get rid of quickly.
Right, right. Because this really goes back to this being a male-focused field, you know, and just like, well, you're not going to need those anymore, you know, and I've seen this many times. It's actually one of the catalysts for me getting into the space and moving outside of fitness and focusing more on nutrition and health is because of a patient I work with who had fibroid tumors. And we were able to, and we did it, by the way, it was a while back, we did an episode on fibroids. So we'll put that in the show notes. But we were able, she had fibroids the size of like, you know, oranges, and they were able to dissolve the size of raisins within a month's time. But this is results not typical. Let me just be clear.
No, but it can happen. Yeah. And even if they don't dissolve in a month, you can still make it better. You can manage the symptoms. Often, not always, not always. But if you can, I think it's really worth looking into that. And this is even more of a good reason to.
Just need to be more judicious in owning like these are your organs, and let's take some time and kind of go through and look at all of our options before we have something taken out. Is like the biggest take home. And again, I think it's important to get self-educated, which is a book like this. This is mandatory reading for any woman, and also if you love women, you know, you should check it out too. But the female brain, the XX brain, is like it gives you. This is like a guide to understanding your body.
Yes, it was meant to be a woman's guide to maximizing brain health and preventing Alzheimer's disease. That was my idea for the subtitle, and then got kind of overruled. But I really wanted to write it as something that is very practical. So yes, it's divided into 3 different parts. The first part is really the research, which I think is very motivating to really understand how your brain works and what hasn't been done and what needs to be done. But what we know so far is quite powerful already. Yeah. It's just that it's not common knowledge. It's just not common knowledge. If you go to an OBGYN or a surgeon who's going to take out your ovaries, there's a good chance that they might not know that that's going to have an effect on your brain. So I think there's a whole education thing that is kind of missing in medicine. I think we should be doing a much better job of really communicating with each other and sharing data, and then providing information to the patients, a really comprehensive information, which is not to say that the doctors don't want to do that. Yeah, of course. Right? It's just something that needs to happen, and we're moving in that direction. But I think it's also important for women to know that and demand information and really understand their brains better. and then take part 2, which is a lot of tests, and it really helps you figure out if there's anything that you should be concerned about, what kind of risk factors are really important for you and not the average statistical woman or person, right? And then in part 3, which is the longest part of the book, is really everything we know from science, no internet, no personal opinions. It's really science-based evidence and actionable research that every woman can really engage in today, including a lot of information on hormones.
Because you talk about that we have a chronological age, we have a hormonal age.
Yes.
And so this is really a big key as we move into this new model of women's health and just health overall for anybody is understanding we have a hormonal age.
Yes. I think it's more of a thing for women for the reasons we just discussed, that all of a sudden you're aging really fast, right? As you hit menopause, your clock, your biological clock and your hormonal clocks are kind of not in sync anymore. And so I think especially midlife, as women approach perimenopause, which is any woman of age 45 and older, sometimes younger, but it's pretty much every woman, something is happening to your brain that really deserves your attention, your full attention, and your support. And I think that's the nice thing that we can do for ourselves to really feel connected to our brains and acknowledge the fact that your brain is not just going to get better on its own. And there are a lot of things that you can do to protect it, to support it, to nourish it, especially in midlife when women's brains seem to be more sensitive to hormonal aging than just straight up chronological aging, which is not putting women down. It's not a condescending thing to say. It's exactly the opposite. We have these hormones. It's not sexist to say that they matter for your brain, which is not to endorse any stereotypes. Right? And women have the chocolate love and the shopping thing. But it's really about understanding that these hormones matter and that we need to just protect them the same way that we think about health for many other things.
Yeah. And I love the fact that you talk about why, just that question, like why do women have to go through this at all?
Right.
And just kind of like, it seems like a philosophical question, but you mentioned that there's only 2 species that are able to continue living after their fertility is over. And it was what whales and women.
And killer whales.
And killer whales, not just the regular.
Not just regular whales, killer whales. There's another type of whale as well that I just learned about, but I think they're rare. But killer whales are quite interesting.
So fascinating. Yes. And you have and this is the thing, is like we try to piece together like why would that be? And you had a great example of how even killer whales, how their social dynamic is.
Yes.
So let's talk about
that.
They
live in matriarchal societies, so the kids stay with the mom for a long time, which is kind of parallel to ancient humans, where the men used to go hunting and were gone for a long time, understandably. And women would stay back and take care of the kids and the elderly.
And the men might not come back too.
And may not come back too, that's true. So there's this theory, which I think is really cute, it's called the grandmother hypothesis, that says that at some point Mother Nature thought, well, I don't want these women to die when they're no longer fertile. I want them to stay with their daughters and become grandmothers and really help. But in order to avoid a reproductive conflict, I'm just going to make them infertile. So they can stay on, they can help out, but they're not going to have kids anymore because we need the younger generations to have kids because that's much more powerful. The kids are going to be stronger and healthier and whatnot. So that's what people think. And I think Mother Nature could have made it a little bit better, right? The transition could have been smoother. But yeah.
Oh man, I love it. So is that what is it called? The grandmother?
The grandmother hypothesis.
The Gram hypothesis. Got it. All right. So now that we've established that this isn't a sexist issue. This is a fact.
It's a fact,
and
yes.
Menopause is something that is just a normal process.
Yes.
And
it's a taboo still in our society. Right? We should really break pretty fast.
Yeah, and it's ridiculous. So if we can, let's first just give a brief summation of we know what tends to happen, and what we see in the media or even movies is like, the hot flashes.
Right.
We see the unstable emotions. Like,
Yes.
what's going on when menopause, when the process actually takes place? Why do women experience these symptoms?
Right, and that's really a good point. And I was so surprised to learn that is not common knowledge at all. So I think it's really good that we get a chance to talk about it. And it really goes back to what we were saying before, that the female brain is wired to respond to estrogen. And all these little estrogen receptors are located in very specific brain regions. They're particularly abundant, for example, in the hypothalamus, which is the brain region in charge of regulating body temperature. So if estrogen doesn't activate the hypothalamus correctly, then the brain is not able to regulate body temperature correctly. Those hot flashes that women get, that's the hypothalamus. It's just that the estrogen is going up and down, it's all over the place, and the hypothalamus gets confused and can't keep your body temperature constant. Or is the brainstem, which is in charge of sleep and wake. So if estrogen doesn't activate the brainstem correctly, we wake up at night or we have trouble sleeping. And then there's the amygdala, which is the emotional center of the brain, which is right next to the hippocampus, the memory center of the brain. So when estrogen levels ebb in these regions, some women get mood swings, some women get depression, some women have memory lapses. All those symptoms, when women say, we're having hot flashes, night sweats, insomnia, depression, anxiety, brain fog is a big one, memory lapses. Those symptoms don't start in the ovaries. They start in the brain, in those very specific regions of the brain that are adjusting to the fact that your estrogens are all over the place.
Yeah. This is fascinating because, with the hypothalamus, like there's so many questions that are being answered in my mind right now. And it's kind of considered this master gland. And it's like an interface, like your endocrine system, your nervous system.
Right.
But so,
it's
of course,
also the region that regulates the production of estrogen and progesterone, right? So it's not being activated correctly. So basically it becomes a loop that is not as efficient as it was.
And being that it's regulating temperature makes complete sense, but also it's a assistive regulator in your body's use of calories.
Yes.
So we see the fluctuation with weight.
Absolutely.
Oh my God.
Many women put on weight after menopause. It really starts in your brain.
Why are you like making everything make sense now, Oh my gosh.
Because as a woman, I really wanted to know.
Yeah.
And I was surprised that I didn't know, that nobody would tell me. My mom didn't tell me a word about menopause. I asked her because for many women, knowing what happened to the mom is a good indication of what's going to happen to you, right? So I was like, Mom, how did you make it? How was it for you? And she's like, I had some trouble sleeping, but broadly okay. So I was like, okay. So there's hope for me as well. But the important thing is then, yes, there's a genetic component, but then your lifestyle plays a huge role. For example, personal example, my mom never smoked. And she went through menopause at 53, which is on the later side. I smoked in high school being Italian. Not nearly as much as my friends used to, but I probably smoked enough to actually create a problem for my ovaries because smoking is the #1 cause of early menopause. Yes. So it's even more of a good reason not to smoke cigarettes, especially for girls.
Poor ovaries. No.
Poor ovary, it's a toxin. It's a very specific ovarian toxin.
So that, again, I think that highlights an important category of toxin exposure.
Yes.
Can affect this process.
For sure.
When we think about the transition through menopause, what tends to come up in the just public consciousness is hormone therapy.
Yes.
So I want to talk a little bit about that before we talk about some of the like real brick and mortar solutions. So what do you think? First of all, bioidentical hormones. What do you think about this? You live in
California. It's such a big deal in California.
Yeah.
Well, hormones are complicated. And there's a lot of confusion on whether or not one formulation is safer than the other and one dosage is better than a compounded dose. And I think we need much better data and more research to really answer all these very important questions.
Yeah.
What we know for sure about hormones is what we should not be doing. I think that's the major lesson that we learned from clinical trials. And especially just what happened historically is that in 1950s, the first hormonal formulation became available, and it was met with such incredible joy and expectations that every woman in menopause was put on hormones, very high doses of hormones, and basically left on hormones for life. And that was before the NIH, the National Institute on Health, even had a chance to run clinical trials to really look at safety and side effects and efficacy. So in 1993, the NIH launched the Women's Health Initiative, which was an enormous clinical trials with tens of thousands of women who were randomized to take either hormones or placebo for years. And the idea was that taking the hormones that the body was no longer making would really help reduce all these things that we talked about, the symptoms of menopause, not just the hot flashes, which were a big concern, of course, but especially the trials looked at risk of heart disease and stroke and blood clots and also dementia. And what happened is that they were very abruptly stopped in 2002, 2003, because very early data showed that the therapy was doing exactly the opposite of what was supposed to be doing. So there was a much higher incidence of heart attacks and strokes and cardiac events for women taking the estrogens and a progestin, which is a synthetic form of progesterone. There was also a higher risk of cancer. And for those women, there was also twice the chance of developing dementia.
Oh my gosh.
So it was an absolute disaster. The trials were stopped. The news really picked on that and really broadcasted this data in a very frightening way. And so just so many women just stopped therapy, basically cold turkey, and there were so many lawsuits, and basically research development kind of stopped at that point. And I think it's been really hard to get back up to speed since then. Just recently, we have some new clinical trials that are much better versions of that trial, in that the Women's Health Initiative had some issues to start with, especially that the women in the trial, both trials, were too old to start with. They were pretty much over 65. You know, if you go through menopause at 50-ish, and your system shuts down, the receptors are just going to shut down because there's no estrogen activating them. And so the whole, your brain, your body just resets and moves forward. But if you then reintroduce the hormones when the system is not ready to receive them, you're not going to get a benefit. You may get a bunch of side effects, which is what happened, especially for the vascular system, which seemed to be the major issue. And then just recently, I'm going to make it really short, but now we have some clinical trials in younger women, and it turns out that if you, especially for your brain, if you take hormones within 6 years of menopause, that is not harmful. It doesn't seem to be particularly beneficial yet, but there's hope. And then, of course, we need to test different formulations and different dosages and different timelines. And what many of us really believe is that you need to probe the system. You need to see, are your receptors active? Is your system ready to take these hormones? When is this the best time to start? When is the best time to stop? And how much of these hormones do you need as a woman? Because there's no average dose. Every woman makes a different quantity of hormones and different qualities. So therapy really needs to be individualized.
Yeah.
And I want to, because I get this question all the time, should I take these hormones? Should I be on hormone? And so what I did is, of course, describe this in detail, but then I came up with flowcharts, being a scientist.
Yeah.
So this is obviously not to replace your doctor.
Which is in the book, the flowcharts.
Yeah, the flowcharts are in the book, and I think you can just start and say, okay, do you have hot flashes? Yes, no. Do you have low sex drive? Yes, no. Do you have blah, 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 blah? Yes, no. And then it gives you options. Are you eligible for hormonal therapy? Many women are not. Yeah. Some women are. Yeah. And if you are eligible, then you go to the next think the next figure and decide whether or not there are risks associated with that based on your age, on your cardiovascular risk score, on your cancer risk score. So there is no universal answer, right? It's not like you're a woman, so you do this. There are a number of parameters that we need to take into account, and I explain them in the book.
Yeah.
So it's a good start.
Yeah, it's creating a broader, like, I think our tendency is towards just, again, one lane or one track thinking, just because of the way that our system is structured.
Right.
And like they were giving out estrogen like hotcakes in the 1950s. And now, the conversation has shifted. And with that said, with it opening up, a lot of people are aware of the genetic component to conditions like Alzheimer's. And so there's a lot of various genetic testing available.
Yes.
And this is a topic you address in the book because
it
taking it upon ourselves to do, the direct-to-consumer tests, which this bothered me for a long time. This is why people are wondering, like, why don't I talk about it very frequently on the show? Is because I saw some bad decisions. People are just at cocktail parties, They're talking. It was like, oh, yeah, you get your genes tested and, whatever. And you can, get your ovaries removed or whatever based off of these tests that come in the mail.
Right.
Now, with that said, here, I got to share this. This is a quote from the book.
Okay.
You state that the problem with many direct-to-consumer genetic tests, which, again, there's some benefits, but you said that the problem might only be slightly more accurate. I'm sorry, let me say it again. You said that the tests might only be slightly more accurate than horoscopes.
Yes.
All right. Now, let me tell you my horoscope today. So I went and looked it up. Okay. And this is my true horoscope today, which I don't know anything about horoscopes, but this is what my horoscope said. Enjoy lighthearted socializing among friends and colleagues, striking a good balance between one-on-one contact and group activities.
How's that even a horoscope? This is like a fortune
That's
cookie.
so general. But guess what we're doing right now? One-on-one. Okay, come on.
For two introverts.
Somebody that's about that horoscope life, they're like, see, I told you.
Yeah.
But yeah, so that's the thing. There's a lot of guesswork involved.
Yeah. Well, I think as a scientist and as a person who is responsible for a lot of patients, I want to know what the test-retest reliability is for any test. So if you're being tested today and tomorrow and in a month, I need to have the same result. And we have CLIA certified labs with known test-retest reliability, which is never perfect, by the way. There's always a margin of error, right? But usually it's quite low and is known for the tests. But most TDCs tests do not even share that information. Like I looked at a few because our patients would come to us and say, I have this ApoE genotype and terrified it's the bad Alzheimer's gene. And I was like, how did you even get it done? They're like, oh, I did like 23andMe, for example. And very often we repeat the test. Actually, we always repeat the test if they're our patients, and very often they don't match. But we use a CLIA certified lab, so I'm much more confident that the results we get are the right ones. Yeah. There was this study published in Nature showing how even the BRCA gene gets really misdiagnosed with these tests.
That's the breast cancer.
Yeah, that's the breast cancer gene, the BRCA1 or 2. And if you don't go to a specialist and have it confirmed, and it turns out you don't have the genetic mutation, I mean, women can really make a decision to have their breasts removed or their, uterus removed, and then find out, oh, actually, perhaps.
Yeah.
Although any reasonable doctor would repeat the test. Yeah. But it was incredible how inaccurate.
Yeah. And even the APOE gene, by the way, which is largely, but not appropriately linked to Alzheimer's, because I think you shared there's maybe like 60% of Alzheimer's patients don't even have it.
Yeah.
Don't even have that gene.
Absolutely.
And it creates so much fear. And this is what I wanted to highlight is that you mentioned that basically receiving genetic information without counseling is dangerous.
It is very dangerous. Receiving any medical information or clinical information without guidance, I think, is potentially a problem. Because what do you do with the information? With some tests, like if your cholesterol is high, at this point, most likely than not, you know what you're supposed to be doing, right? You watch your diet, your exercise, and other parameters. You ask your parents, did they have high cholesterol, is it genetic or not? But then there are all these new tests for which the test is only as good as the doctor who's going to manage your response to the knowledge of the test, and who's also going to know what to do about it.
And that's what you really focus on in the latter part of the book.
Yes.
What are the things we can do to manage this risk, to make all of these processes much more graceful, and just to help you to feel better, perform better.
Yes.
And so I want to talk about that. You mentioned one earlier, which is a risk factor, which is smoking, and the impact that can have on ovaries.
Health,
But some of the things that we can do that you talk about in the book, steps to a well-nourished brain specifically, and I want to talk about some of these. One of them is to protect your brain with antioxidants.
Yes.
So why does that matter?
That's a good one. Well, I think it really matters for a number of reasons. Number one, that the brain is the most metabolically active organ in the body. And by virtue of being so energetically active, is also really sensitive and really vulnerable to oxidative stress. And oxidative stress is something that happens in your body and your brain as you age. It's just a natural part of getting older. And it is, in fact, a product of glucose metabolism, creating, oxygen peroxide or these oxidants. But the good news is that you can kind of balance it out by importing antioxidants into your body and your brain by means of a healthy diet, which is really one of the few ways that we can reduce oxidative stress is through the diet. And then the other reason that oxidative stress is such an issue, especially for women around midlife or menopause, is that we show those energy reductions in the brain that are potentially related to oxidative stress, or to the brain becoming even more vulnerable to things like oxidative stress and inflammation. So antioxidants are really important. And the good thing is that they come from foods that actually taste good. We were talking about noni juice, and it's not exactly palatable, but many veggies and fruits and nuts and seeds contain antioxidants. Even caviar contains a little bit, but just a little bit. It's mostly really vegetables and fruits, which one should be eating anyway. But the important thing to know is that for women, specifically, we have evidence that 3 vitamins in particular are really helpful against oxidative stress. And these are vitamin A, or beta-carotene, which is the precursor, and then vitamin C and vitamin E. And the interesting thing is that vitamin C and E are also really helpful to alleviate the symptoms of menopause. So see how everything seems to be really going hand in hand.
Yeah, absolutely. And you mentioned in the book there was large-scale studies found that elderly people consuming a good amount of vitamin E had nearly 70% lower risk of developing dementia. Yes,
especially when taken together with vitamin C. So if you have both. And the thing is, they had it in their diets. So we need more research on that, but it looks like obtaining these nutrients, the antioxidants, from the diet is actually better than getting the same nutrients from supplements, because they're more biologically active and they contain more varieties of the same vitamin. So vitamin E comes in 8 different isoforms, and each one of these isoforms has a slightly different effect on the brain. Like the alpha variety is more for oxygenation, the gamma variety increases blood flow a little bit more. So when you eat almonds or olive oil or other fruit, other nutrients, other foods that contain vitamin E, you get all these different forms. Whereas usually when you buy the supplements, it's just one of the variety. But also there's a lot more in food.
Yeah, the cofactors.
The cofactors, the interactions between different nutrients and the experience.
I hope everybody heard that. There are different forms of vitamin E. It's not just one thing. Same thing, we know about vitamin D, but it's the same thing with vitamin C. It's the same thing with vitamin E.
The B
vitamins, we know about that category. You know, and so when you're taking a supplement and it says, getting my 300% my daily value of vitamin E, is that the kind you really need, which is, again, if you lean towards food. And so you mentioned olive oil, almonds, so nuts and seeds, avocados is another good source.
Avocados are great.
That's so good. So that's The first
food is
one.
medicine. Yes, it's really important.
Hippocrates said it.
Yes.
Another one here is to manage your carbs. So this is interesting dichotomy because you're saying we need glucose for the brain to be able to do its thing, but we gotta be cautious.
Careful. Yes, I think so. There's interesting research that was really done in women that never really gets shared outside of academia, and I didn't even know that much about it until I really started looking into that. There are these beautiful studies, mostly done at Harvard, like the Nurses' Health Study is a huge one, really fabulous, and they looked specifically at women and clearly showed that carbohydrates are good for women. And I think it's good to talk about it right now because, you know, with all these high-fat diets being so popular and so trendy, there's a tendency for many, obviously men, but also women, to really stay away from carbohydrates and almost be fearful of carbohydrates. So I think it's important to know that they're not necessarily bad for you as long as you eat them, obviously, in reasonable amounts. And also it's important to talk about the quality of the carbs. There are carbohydrates that really negatively impact your body, mostly by negatively impacting your hormones. And then there are like the refined carbohydrates, like white sugar, white bread, and refined pasta, pizza, all the good things. And then there are the, you know, so-called good carbs that don't impact your insulin levels nearly as much, but they do provide enough glucose and fiber, like complex carbohydrates. And that has been shown in a ton of studies to be really correlated with improved health in women. So a lower risk of cognitive decline, a much lower risk of heart disease and stroke, lower risk of depression. And just for context, I'm not saying that one shouldn't be eating the fats, right? It's more like because women's bodies and brains are so dependent on estrogens, at least prior to menopause, it's helpful to know that estrogen is a carbohydrate burning hormones. So it really helps you burn the carbohydrates as a woman. So even if you're on a high carb diet, as a woman, you're still going to burn all those carbs. Whereas men, because they have more testosterone and less estrogens, tend to put that away as glycogen in their tissues. So the metabolism of carbohydrates differs between the genders. Not completely, but a little bit. So I think it's good to know that. Just go for fiber-rich foods that also provide glucose for your brain. And I would also like to mention that of all the diets out there, the Mediterranean diet has been shown to really support health in women, overall health. Like women on this diet have a much lower risk of cognitive decline as compared to those on more like Western diets. They have a much lower risk of heart disease, of stroke, or depression, and of cancer. And they also have like 30% fewer hot flashes. So I think it's something good to know because the Mediterranean diet is a flexible diet. It's mostly vegetables and fruits and whole grains if you eat them, legumes if you rather have legumes or don't have them. You know, but have your veggies and your fruit. And then fish is a big part of the diet. Healthy fats, like we don't have avocados, but let's throw it in there. But extra virgin olive oil is a really good source. And meat and dairy products are consumed in moderation, which is not you shouldn't eat them, right? Just not breakfast, lunch, and dinner, or that should be more like a treat, I think. And of course, no processed food.
And this is a good segue because you mentioned one of these is to choose the right fats. And in the Nurses' Health Study, you noted that when we're looking at women taking full-fat milk versus low-fat milk, there was a big distinction there.
Yes, in that the full-fat milk was actually better for fertility. That's a study that
specifically
for fertility. However, fertility is related to ovarian health and hormonal health. And the longer you're fertile, the later you go through menopause. So in some ways, it must be good for your brain
of course.
as well, right? And the point being that cows that make milk are pregnant cows. And so they have all the hormones beyond lactate, but they also have a lot of estrogens in the milk. But when you remove the fat from the milk, you're also getting rid of the hormones that are bound to fatty particles, right? Hormones bind to fat. And what you're left with is more like a bizarre hormonal cocktail that is more androgenic than estrogenic. So there's this theory that by drinking low-fat or no-fat milk, you're effectively getting a lot of androgens inside your own body. I don't think that quantity really, is that much, but it does seem to play some kind of role.
Yeah. And it's a simple principle to follow as well. Like, and you just outline it very clearly. Just go for the full fat versions. This is how nature would produce it. Right. It tastes better. But we know we suffer through, like, growing up, we had one of these like a WIC program here in the U.S. where it's basically like government food stores. We would go to food pantries and we get these kind of government handouts. And one of the programs, we got skim milk instead of, the vitamin D full fat milk, which is great. But I remember pouring that skim milk over my cereal and just like really literally feeling like, yes, like I should just, why don't I just use water? Like this is just white water.
Yes.
And it would piss me off as a kid. And so I just would just eat the cereal dry rather than suffer through the white water.
You poor thing.
So, but now we know
but
again.
I agree. I mean, what's the point? It doesn't taste good.
Yeah,
for sure.
It's probably like, let's just give it to the poor kids. So there's so many different important facets of having a well-nourished brain that you outline. I just want to talk about maybe one or two more. I thought it was really fascinating when you mentioned feed your microbes.
Yes.
And how does that relate? When we're thinking about brain health, how does that correlate with the microbes?
Yeah, that's a really good question. And as usual, I go to how is that specifically important for women? But the point is that the microbes in your guts do have, the health of your microbes has an effect on the health of your brain. So we know that if you have more of the bad microbes and fewer of the good ones, there's a tendency to suffer more from anxiety, for example, and depression. And sometimes anyone who's ever had food poisoning knows that you can't think straight, right? So they do cloud your mind. If you have a problem in your gut, it can have an effect on your brain. And something that is interesting to me as a women's brain advocate, a specialist, if you will, is that fiber is excellent for really supporting gut health and also stabilizing hormonal levels. So by feeding your guts the right way with fiber, with oligosaccharides, which are the specific carbs that they're non-digestible for us, but they feed the microbes in the gut, and taking prebiotics and probiotics, hopefully from foods, but also from supplements, you're not only supporting digestive health, but also you're supporting your hormones. And I think this is something really interesting and important to just to keep in mind. You're doing something good for your tummy, for your hormones, and as a result, for your brain as well.
Yeah, it makes so much sense.
Yes.
We've been sprinkling in this conversation for years just about how powerful these microbes are in influencing our health. And just even understanding we have all of our human genes, but then all of these microbes, these trillions, they have their own genes.
They have their own genes.
And we're still just scratching the surface on our understanding.
Yeah.
So definitely much more to come there. And I was just like, of course, like it has to be highlighted in your book as well. But
it's interesting to me about microbes and how they're related to the brain is how surprising that was. Right, when that correlation came out, everybody was kind of skeptical or not quite sure, and now everybody's really into that. And I think that's a major flaw with Western medicine, how we tend to think of our bodies as a bunch of separate organs that don't speak to each other. And that's the same for women's health, because it's not about your brain or your ovaries or something else. They're a system. They speak to each other. And in my opinion, if you have a problem with your foot, your brain knows about it, right? Because the videos say for sure, your brain must be like, And any big change in any organ of the body must have an effect on the brain.
Yeah.
And I think we should really move towards a more integrative approach to health that considers all of us.
This is a perfect segue to the last thing I want to ask you about, which is addressing the stress component of brain health.
Let's do that.
And this is definitely not talked about enough when we're talking about the female brain and how stress plays a big part in this.
Well, stress plays a really big role for men and women, of course, and is the silent killer in our society. It really puts people at risk for heart attacks and strokes and inflammation, and it impacts your brain as well. And for women in particular, there are some very interesting brain imaging studies showing how if your cortisol levels are really high, the levels of your main stress hormone, your brain suffers, even already in midlife. And that really high cortisol levels correlate with brain shrinkage and memory impairment already when you're 50 years old. But the brain shrinkage was only found in women and not in men. So in men, if you have high cortisol levels, your memory might suffer and your performance might suffer, but your brain is still kind of compensating for it. Whereas women's brains, especially post-menopause, show signs of shrinkage as a response to high stress levels, so chronic stress levels. And this is telling, I think, because we know that stress can literally steal your hormones. So cortisol, again, the main stress hormone, works in balance with your estrogens. So if your cortisol goes up, your estrogens go down. If cortisol goes down, your estrogens go back up. And this is because they have a common precursor, which is called pregnenolone. So the body needs pregnenolone to make both cortisol and estrogens and testosterone. And if you need to make more cortisol, the body's going to steal the pregnenolone away from your sex hormones and just shuffle it towards the cortisol levels. And so your hormones just plummet. And unfortunately, there's a ton of evidence that women suffer stress or experience stress in a more severe way than men do. And again, it's not about comparing. The point is that women are stressed out. And it looks like the peak is somewhere between the age of 25 and 45. And for most women, really maps onto the perimenopause, which is honestly when most women have small kids and they have full-time jobs and they're trying to hold on to their husbands as well. And they may have elderly parents who need help. So there's a whole lot going on, and then stress levels really go up, and you don't have time for yourself, and that also really has consequences, not just on your health, but also on your brain health. So for all husbands out there, partners or friends, help them out. Help those women out.
It's good advice. We mentioned this earlier, and, with your daughter breaking the boards and you taking that break, just having that teamwork, because this is something we evolved having. We evolved having a tribe, community, but now we're isolated. We have our little family nook somewhere, and oftentimes we're not by our parents anymore or other, caregiver support systems. And sometimes we don't even have two parents, and so I think it's important for all of us to open our minds, because no matter what situation you are in, first of all, if you do have access and support, it's a blessing. Use it. Be more proactive in it. And even understanding just how much stress and just being tied up in all this stuff is hurting your brain. And so, but if you are in a position where you don't feel like you have that, make it an intention. Open yourself up to, because for some people it's just like, well, I don't like my mother-in-law, or whatever it is. Another stereotype, okay? I love my mother-in-law, all right? But that might be a situation where you just open yourself up to better communication and understanding that is another vital influence for your child to have that wisdom input, and for you to have some time to yourself while your child is in the hands of somebody who you trust. So open yourself up. Friends and family, expanding your communication, your community is super important. Humans, our genes expect that of us,
Yeah, it's true. And also for introverts who perhaps don't want to go that way, there are other things. There are other stress reduction techniques, like green time over screen time seems to be a big one. Meditation helps a lot of people. And especially for women, there were some interesting clinical trials showing how a regular meditation practice, even just 12 minutes a day, really lowered cortisol levels and improved oxygenation to the brain, improved blood flow to the brain, and also reduced the symptoms of perimenopause and menopause.
Blood flow is super important.
It is important. If anyone is into meditation, I think it's a great asset. It's a great tool to cultivate.
Hey, if you like this video, make sure to check out this video right here.
Not only are we damaging our gut bacteria by eating horrible foods with high sugar and preservatives, emulsifiers, etc., we're also putting them in a dark place for over 24 hours where they don't know what night and day is, and they're dying off that way.